Hi, today we're diving into the fascinating world of geometric sequences and series. First, let's take a look at what we'll be covering today. We'll start by defining these concepts, then explore their essential formulas, and finally uncover some crucial tips for your external exams. But before all that, let's confront a real world scenario, a viral challenge. Imagine a new online challenge. On the first day, 20 people participate. Each subsequent day, the number of new participants is 1.6 times the number of new participants from the previous day. Can we predict its growth? Let's find out how geometric sequences and series provide the tools to solve it. Now, let's start by formally defining what a geometric sequence is. A geometric sequence is a sequence of numbers where each term after the first is found by multiplying the previous one by a fixed non-zero number. We call this fixed number the common ratio denoted by R. For example, in the sequence 2, 6, 18, 54, and so on, our first term is 2 and the common ratio is 3 because each term is 3 times the previous one. The general term or nth term of a geometric sequence can be found using the formula un is equal to u1 times r to the power of n minus 1. Here, un is the nth term, u1 is the first term, and r is the common ratio, and n is the term number. Now remember, this formula is conveniently available in the formula booklet. Now what about a geometric series? Simply put, a geometric series is the sum of the terms of a geometric sequence. So instead of comma separating the numbers, we have the plus sign like 2 plus 6 plus 18 and so on. Now let's find the sum of the first n terms denoted as Sn. We have two equivalent formulas. We have Sn is equal to u1 times r to the power of n minus 1 over r minus 1, or we can say Sn is equal to u1 times 1 minus r to the power of n over 1 minus r. Both work, just pick the one that feels more natural for your common ratio r. And yes, they are both in your formula booklet. Now, S infinity is equal to u1 over 1 minus r. It is in your formula booklet, and we use it when absolute value of r is smaller than 1, which means our sequence will converge. Consequently, the sum will converge. And what we mean by converge here, it means that when you graph the sequence, it will reach a certain number, but it will not be equal to it. So in that case, y equal the answer of S infinity is a horizontal asymptote to the graph of the series. Now, if the absolute value of r is greater than or equal to 1, then these terms do not get smaller fast enough, and the sum just keeps growing, meaning that the series will diverge. Moving on to some important hints and tips for your external exams and even your IA. Firstly, always identify u1 and r correctly from the problem. Now, this is the foundation of your solution. Once you have the given, you can decide how to move on by choosing the correct formula from the formula booklet. Secondly, now be careful with n versus n minus 1. It's a common mistake to use n in the exponent for un instead of n minus 1. Doubly check that. Thirdly, for sums to infinity, always explicitly state the convergence condition, absolute value of r is smaller than 1. Now, if it's not met, explain why the sum to infinity does not exist. This is the case where it is divergent, of course. Now, and finally, when a problem asks you to find n, for example, which day something happens, you will almost certainly need to use logarithms. So refresh your logarithms rule to ace these questions. Alright, now, with our definitions and formulas in hand, let's tackle the viral challenge problem. First and most importantly, let's identify our u1 and r. From the problem statement, the first day has 20 participants, so u1 equal to 20. Each subsequent day, new participants are 1.6 times the previous day, so our common ratio is r equal to 1.6. Now, for part A, how many new participants join on the 6th day? This asks for a specific term, so we'll use the general formula un is equal to u1 times r to the power of n minus 1. Replacing our values, we get u6 is equal to 20 times 1.6 to the power of 6 minus 1, which approximates to 209.7152. Since we're talking about people, we round this to approximately 210 new participants on the 6th day. Now, next, let's talk about part B. What is the total number of participants after the first 8 days? Now, since we are asking about the total, this is the sum. So we use the sum of a geometric series formula. Sn is equal to u1 into r to the power of n minus 1 over r minus 1. Replacing our values in this formula, we have n equal to 8, and S8 in this case becomes 20 into 1.6 to the power of 8 minus 1 over 1.6 minus 1. Notice here that we used r to the power of n minus 1 over r minus 1 since r is equal to 1.6, which is bigger than 1. Now let's compute this, and this will approximately be 42.94967. Always use at least 4, 5, or 6 decimal places with the 3 dots to show that this is the exact answer, and to make sure that you get this accuracy mark at the end of your solution. So S8 in that case becomes 20 into 42.94967, 3 dots minus 1 over 0.6. My advice, when you type it on the calculator, always use the exact answers. Do not take the rounded answers, otherwise your final answer will be rounded to incorrect significant figures or decimal places, which means that your final answer will be incorrect as well. Now this approximately gives us 1398.32. Rounding for participants, and since we don't have a fraction of a participant, we have approximately 1398 total participants after 8 days. Finally, in part C, on which day will the total number of participants first exceed 100,000? This requires us to set an inequality using our sum formula. So we know that Sn should be greater than 1000 since we have exceed. So we write 20 into 1.6 to the power of n minus 1 over 1.6 minus 1 should be greater than 1000. This tells us that we have 20 into 1.6 to the power of n minus 1 greater than 60k. Now dividing both sides by 20, we have 1.6 to the power of n minus 1 is greater than 3000. Adding 1 to both sides and then using logarithms, we get n ln 1.6 is greater than ln 3001. Now keep in mind that we can also use log base 1.6. So we can say n is greater than log base 1.6 of 3001. Now divide by ln 1.6. Since ln 1.6 is positive, the inequality sign doesn't flip. So n is greater than ln into 3001 over ln 1.6. Now keep in mind, if you use n is greater than log base 1.6 of 3001, you have to pay attention to the base. If the base is bigger than 1, then in that case, you keep the inequality sign the same. But if the base is smaller than 1, in that case, we flip the inequality sign, since when we use ln, for example, this will show us that we are divided by negative. That's why we have to flip the inequality sign. Now calculating these values, we get n approximately 17.03. Now, since n must be a whole number representing a day, and it must be greater than 17.03, the challenge will first exceed 100,000 participants on the 18th day. Amazing how quickly it goes, you see? Wow. And that's how you conquer geometric sequences and series problems. From predicting viral spread to understanding financial growth, these concepts are incredibly powerful. Now, to get more practice and check your understanding, head over to our website to do more practice. The link is in the description below. Don't forget, discussion is a crucial part of learning. So if you have any questions or comments, feel free to leave them below. We'll reply to them as soon as possible. Thank you for learning with us, and see you next time.